key events in the history of life. With stellar metamorphosis, we can go ahead and attach when the life was beginning inside of what eon, and then look at the diagrams that have been drawn up by Baz and I and figure out what we're actually looking at, what stage of life evolution some of these stars are in. And now, this is a rough estimate, but it's definitely very important. And you're not going to hear anything to do with this on any YouTube video or in any scientific paper across the entire planet. This one goes out to Celeste, of course. There are 4 major eons. There's the Hadean, Archean, Proterozoic, and Phanerozoic. 4 major eons. There's the time frame for them is 4.54 billion to 4 billion years ago, 4 billion to 2.5 billion years ago, 2.5 billion to 541 million years ago, and 541 million to present time. Now, the reason why I want to talk about this is it puts all the pieces of the puzzle together. It does it pretty seamlessly. Now, not exactly seamlessly, I should have used a different word, but it just, boom, it hits you. You're like, wow, there's something really to this. Now, when you look at this graph is a little off. This had served as a representative sample. When you draw the x-axis and you go up, it's not going to directly match. This is more or less a representative model. I have more honing to do with it. But these giant eons of Earth's time, well, I'll go ahead and read this out to you, and then I'll show you another graph here to make it all, wrap it up, make it all make sense. The Hadean eon, 4.5 to 4 billion years ago, it says here, the Earth formed out of debris around the solar protoplanetary disk. We all know that's false. There is no life. Correct. Temperatures are extremely hot. Correct. With frequent volcanic activity in hellish-looking environments, hence the eon's name, which comes from Hades. No volcanic activity, sorry. That's false. But it is extremely hot. They got that right. Very much hot like Hades. Probably even hotter than Hades. The atmosphere is nebular. Bingo! The atmosphere is nebular. It's a star-like atmosphere because that's what the Earth is. It's an ancient star. When the Earth was very young, during the Hadean era, it was bright and hot like the sun. The atmosphere was very nebulous and it was extremely hot. Tens of thousands of degrees Kelvin down to like around 4,000 degrees Kelvin. Possible early oceans or bodies of liquid water? False. The oceans didn't form yet. It takes time for the oceans to form from the hydrogen and oxygen clumping together. The moon is formed around this time, probably due to protoplanets' collision into Earth. False. The moon was formed long before the Earth even existed. The moon is one of the Earth's planets when the Earth was in its Hadean era, when it's in a sun-like star era. The Earth's Hadean era is when it was a young hot star right up here. 4.5 billion to 4 billion years ago. Next, the Archean era, or Eon, I should say. 4 billion to 2.5 billion years ago. Prokaryote life, the first form of life, emerges at the very beginning of this eon in a process known as abiogenesis. The continents of Valabara, and Kenor land may have existed around this time. I've never heard of those before in my life. I took geology. The atmosphere is composed of volcanic and greenhouse gases. Well, they got greenhouse gases in there, correct, and maybe volcanic gases, but no volcanoes yet. It's still a gas giant in this stage. Very, very hot, very big, and not a lot of land. There's no land yet. There's no solid surface yet. And then you have the Proterozoic, which is 2.5 billion to 541 million years ago. It says here, the name of this eon means early life. Eukaryotes, a more complex form of life, emerge, including some forms of multicellular organisms. Good job, guys. Bacteria begin producing oxygen. False. Bacteria aren't needed to produce oxygen. Oxygen is a byproduct of cellular evolution itself. It comes from the oxygen as ions combining with other oxygen, making oxygen gas. No bacteria is needed. Shaping the third and current of Earth's atmospheres. I don't know what they mean by that. Third atmosphere? It's always had its own atmosphere. There's only one atmosphere that undergoes metamorphosis over time. Plants, later animals, and possibly earlier forms of fungi form around this time. The early and late phases of this eon may have undergone Snowball Earth periods in which all the planets suffered below zero temperatures. The early continents of Columbia, Rodinia, and Panatia, in that order, may have existed in this eon. I'm not sure what their obsession is with continents. I don't know. Maybe they should focus on the entire star itself. I don't know. And then you have the Phanerozoic, 541 million years ago to the present. Complex life, including vertebrates, began to dominate the Earth's ocean in a process known as the Cambrian explosion. Pangea forms and later dissolves into Laurasia and Gondwana, which in turn dissolve into current continents. Again, their obsession with continents, I don't know why. Gradually, life expands into land, and familiar forms of plants, animals, and fungi begin appearing, including annelids, insects, and reptiles. Hence the Eon's name, which means visible life. Several mass extinctions occur, among which birds, the descendants of non-avian dinosaurs, and more recently mammals emerge. That's our ancestors. Modern animals, including humans, evolve at the most recent phases of this eon. Now I just went over them. I'll show you a little description of where the objects are in our star system are. Here I have a little printout that I stole from online. You have your Hadean, that little pink area. You have your Archean, that gray area. Proterozoic, and then you have your Phanerozoic, which is the shortest period. This is where the really complex life starts springing up. This is where the early life is. This is where life and the complex molecules are at the very, very beginnings of it. And this, the Hadean era, is where the Earth is way, way, way too hot to do anything interesting. Well, interesting in terms of life. Now, all you have to do is take these stages and match it to the diagram. Here, let me fold this up real quick. It's surprisingly accurate. Not really. But one day it might be accurate, one day. You just match those bad boys up and boom, there you go. Of course, this graph right here should be a lot shorter because this area down here is dead. So just, I don't know, let's see if I can match it up. Maybe it'd be more like that. But anyways, you get the point. But what I mean here is that the Hadean eon is too hot, sun-like stars, red dwarfs, early stage brown dwarfs. The Archean era are Jupiter, Saturns. Those are the objects between 550 to 700 million years old. And then you have your Neptunes and Uranuses, which are about 1 billion years old. And those are the objects where the prokaryotes start forming. Those are the very simple life forms that are the beginnings of plant life, I believe. Prokaryotes are. I think I got that backwards. Maybe eukaryotes are the beginnings of the animal life, where the mitochondria enter into the cell and start doing weird stuff. But I can't remember all of it. But the prokaryotes start forming. I don't know if you guys got that around Neptune and Uranus stages interior to the object. So they're actually very, very interesting. They're not these dull, uninteresting ice giants as per 1970s theorizers, where they're just like, why spend all this money to send probes over there? They're too far away. They're not interesting. They're, whatever. But actually, when you go into the atmosphere, I guarantee you're going to have some extremely complex chemistry going on. But, the astronomers and researchers, they struggle getting funds. So, they have to bend the knee to the government and, whoever gives them the cash. And if they don't like the ideas, there's beginning of life in Neptune and Uranus, they're going to shut them down real fast. But anyways, ocean worlds come around. We don't have an ocean world. That's where atmospheric oxygen begins dominating the atmosphere around, 2 billion years into the star's evolution. And then you have Proto Earths, which still have deep oceans, but the oceans are beginning to evaporate. Of course, the Snowball Earth, I don't know if you guys got that, but Snowball Earths are around the Proterozoic age. And that's when the Earth is completely a deep ocean object, and it's going from star system to star system, and it's still evolving internally. It freezes over at one point, and then it goes back to oceans again, and it freezes over again, and over time the atmosphere dissipates and the water starts evaporating, and the land becomes more and more and more dominant inside the interior. That's, you know, as it's forming. I'm not doing this a lot of justice, so a lot of this from memory, but and you have the Proto Earths, which still have oceans, thick oceans, but the atmosphere is really dense and thick right about here. And then those Proto Earths, eventually the oceans continue evaporating, and then you have your multicellular eukaryotes, and then the land starts peaking up, and then you have objects that start growing on the land, and then they start walking on the land, and before you know it, they have Jeffrey Walensky's talking and making YouTube videos. Yeah. But anyways, I wanted to share that with you guys. Neptune and Uranus, about 1 billion, 1.1 billion, 1.2 billion years old. Jupiter, Saturn, 550 to 700 million. And all the Hadean Eon stars, we can see them in the night sky. They shine really bright. What we're going to be looking for are the Phanerozoic stars, which are forming their complex life. Of course, if you do the math, simply if Earth is 4.5 billion years old and the Phanerozoic age is 500 million, you're looking at 1/9 of all the stars, given they're all like the Earth, will be in some sort of Phanerozoic stage if it had enough time to form its interior and make the Earth-sized object in its interior, and, you know, didn't have some unfortunate event like being too close in orbit around another hotter host, which ripped it apart. I already went over that in the earlier video that explains why there's small moons that don't have anything going on, no life, no oceans, no nothing. But I just wanted to share these eons with you guys, and the geologists, they got it right, but there's a lot of things that are incorrect. They still have the idea that Earth has always been the size that it is now, regardless if all the observational evidence points in the direction of this theory, in which case the majority of the Earths that we observe are much, much more massive and much, much younger. But of course, it's going to take some time to move, you know, past the outdated theories and sort of move on, if you will. All right, you guys, take it easy.